Hello and welcome to my channel of Hireable Coder, and in this video I'm going to show you how you can detect whether an input number is prime or not. Now this is also a very basic example, so this is only for the people who are starting to code, like people who are in their high schools or maybe people in their colleges who are just starting to code. If you are already an experienced coder and if you are still viewing this, would love to hear any feedback from your side. So coming back, the challenge is I have to detect whether an input number, maybe it's 13 or 15 or 100 or 27 or 29, I have to detect if it's prime or not. So what is the definition of a prime number? The definition of a prime number is that the number is only divisible by 1 and itself. So if there is any divider of the program apart from the number 1 and the number itself, then that is not a prime number. So, and how do we determine programmatically whether it's a prime number? Normally we will think that we will keep on dividing the target number from 2 till half of that number. And if there is any divisor, if the number is exactly divisible by any of those divisors, then of course the number is not prime. But is there any better way? Like, is there any quicker way? Yes, there is indeed a quicker way, which is dividing from 2 till the square root of the number. So for example, we want to find out whether 1003 is prime or not. Then instead of dividing 1003 by 2 all the way till 502, we can actually stop dividing 1003 till square root of 1003, which is I think around 31, 32, something like that. So that's a quicker way. So let's see the Java version of the program. Yeah, it's a bit longer program because it has got some validations which I will also explain. But if you look at the last function or the last method, which is prime, is the crux of the entire program, which means is the main method, or rather is the method which is actually determining whether your input number is prime or not. So if you see that we have a for loop which iterates from 2 till the square root of the target number, and for each of the iterations, for each of the elements or each of the items of the for loop, which is I, we are dividing n by I and we are checking if the remainder is 0. So if the remainder is 0, of course the number is divisible and then it's not prime. So as soon as we find that the remainder is 0, we will actually exit the loop saying that it's not prime. So that's it. But another important aspect of this program is I have added some additional validations, like I'm checking whether the input itself has been given and whether the input is also a number or not. So in our real life programs, we need to add all these kind of validations because it's not only important to actually do the main work of the program, but it's also important to ensure that the program does not crash because of some junk inputs or because of some other issue. So we need to carefully safeguard the program from all those things. So that is why you will see that here we have some validations, like I have checked whether an input has been provided, and also if the input is there, then whether the input itself is a number or not. I will show a demo of this program when you will see how it is done. So that's the JavaScript version, the Java version. Now we will see the JavaScript version. It looks very similar, little bit concise, little bit less verbose. So that's why maybe it's easier to read, but if you look at it, the main logic remains same. The syntax of course is a little bit different. The main logic is again within that isPrime method, which is iterating a loop from 2 all the way till square root of the target number, and I'm dividing n, which is the target number, by the loop by the loop iterator, which is I, and if I'm seeing that it is divisible, then of course it's not prime, then I'm exiting the loop. But also, just like the Java program, here also we have validations to check that a target number has been provided, and the target number is also a number and not something which is an alphanumeric or non-numeric input. So that's it. Now let's go ahead and see the demo while I run the program, both Java and JavaScript. So this is the Java version of the program, and as I mentioned that this is the main function which calculates or which determines if the target number is prime or not, and these are some validations, but let us first go ahead and compile and run the program. So I will first compile the program using javac and then isPrime.java. The program got compiled, and then let me try to run the program. Yeah, so when I'm trying to run the program, I need to provide an input. So it's saying that the target number, which is the input, has not been provided. So now I will provide an input, like say for example 12, and I want to determine if that's prime or not. So that's not prime. Now I will give an input which is 13, and the program will determine whether it's prime or not. So 13 is prime. Now I will give another input, 29. Is it prime? Yes. And maybe 1003, that's not prime. So now let me give an input like this. So provided target is not an integer. So this is what I mean by validation, and in our real life program we have to add this kind of validations. Like, so what I'm doing initially here is I'm checking this args length equal to 0 means there is no input. This args is basically an array which contains all your command line inputs. So command line inputs means anything after Java and the program name. So 13 is the first command line input. So any input that you provide to a Java program after the name of the class is actually taken in that args array and is the command line input. So here I am checking if the command line input length equal to 0, if that array length equal to 0, or the first element of the array is blank, then I know that no target has been provided. And that's why I am printing this message, and then I am exiting. Then I am checking if the target is there, then I am checking if the target is an integer. So I have written a function to check if it is an integer. So this is another Java utility, like if it is an integer, so I'm trying to convert the string into integer because any input that will be taken from the command line will always be string by default. So I will now try to understand if that string actually contains an integer by doing an integer.parseInt. It's a very standard way of determining in Java whether a string is an integer. And if it is not an integer, then it will throw an exception. If it is an integer, then it will not throw the exception. So that is why I'm checking here. If it is an integer, then get the integer out of the string and then pass that integer to the isPrime method, and the isPrime method will finally say if it is prime or not. So you might not be able to understand everything of it, but my suggestion is please go ahead and copy the program and run it and then start tweaking it. That's how we learn programming. We do not get the entire thing, everything in one go, but if you get the overall construct, the skeleton, the if else blocks, and the way in which I have structured the functions and the way in which the logic is executed, it is good as a starting point. Now we will go ahead and see the JavaScript version of the program. Again, it's very similar loop and very similar validations. JavaScript program is easier to run. So it's also saying I have not provided any input, so now I will provide an input. Provided input 13 is prime, true. Yes, 13 is prime. Then I will test with 14. 14 is not prime. Then I will test with maybe a non-integer. It's a non-numeric input. So that is how it is checking in JavaScript. Very similar in concept and the skeleton of the code. Of course, the syntax differ. So that is why, again, my suggestion is copy the JavaScript and run it. And if you are still struggling to set up your laptop to be able to code in Java and JavaScript, please refer to my other video where I have laid down how you can actually set up VS Code and Java and JavaScript in your laptop. So that's it. Thank you for your patient listening. I hope this session was useful, but please go ahead and try it out yourself. And this is my blog post, which you can refer to, literally copy the code and try it out yourself. And if you really like my video, then please go ahead and subscribe to my channel and also like the video, because that would motivate me. Thank you again.